Okay, so what we got from that is that pie charts would be better if they were relative frequency, because percentages would be better. So pie charts are okay, but relative frequency is the best pie chart because the size of the wedge is determined by the percentage. Okay, here we have a contingency table, and a contingency table is also known as a two-way table. And it gives us an opportunity, instead of looking at a frequency table, it gives us an opportunity to make a comparison between more than one variable. So we've got a variable of class, meaning the birthing of the people on the ship, and we've got survival, whether or not they survived or they did not. And then the interaction of those two variables. And what we can see is, here's the data we had from the frequency table, is that first class was 325, second class 285, third class 706, crew was 885. But then we've also got how many people survived. 711 people survived the Titanic, and 1,409 people died. And then we've got the interaction of these two groups individually. So what this cell says right here is that those people that were first class and survived, 203. Those people that were first class and died, 122. But that is something that we understand because we've seen tables like this before. Now, when we talk about two distributions that are really important. The first one is called the marginal distribution. And the marginal distribution is data that comes from the margins. That's margins. Margins. There we go. I can spell. Margins. It comes from the margin. And what is the margins? It's the data on the side. So what you're looking at is you're looking at the totals. When we talk about the marginal distribution of survival, we're taking a look at one variable only, there we go, one variable only. And that variable is the variable survival. And our question is, how does that variable break down? What is the data that is in the margins for survival? And your choices are here. It is, well, you had the opportunity to be alive. You had the opportunity, awkwardly, to be dead. And how many people were alive? Well, we saw that in the last table. It was 711. So 711. And then those that were dead was 1490. So that is the marginal distribution for survival. If I erase that real quick and I say, oh, what is the marginal distribution for class? Then we're looking for the totals in the margins, and the margins are the edges of the class. There was 325 people first class, 285, 7 for third. I remember this one was 885. And I would say, oh, you could be first, you could be second, you could be third, you could be crew, and I'd put the values there, 325, 285, 7, whatever it is, and 885, and that would be the marginal distribution for class. So marginal distribution means the values in the margins, the totals for one variable only, and I'm looking at the variable of class. This is what we talked about. This is 673 people in the crew who were dead. We understand that already. The other distribution that we need to talk about is the conditional distribution. Conditional distribution shows the distribution of one variable under the condition something has happened. Okay? This says the following is a conditional distribution of ticket class conditional on having survived. So, under the condition, under condition of surviving, what is the class distribution? So what you're doing, and here's what's really important. What you're doing when you say under the condition of surviving, you're saying given, another word for that, given you survived. How did that survival group break down? And what you're doing realistically is you're going to that distribution and you're redefining what your population is. My population is no longer the entire number of people on the boat. It's just those that survived. So we're going to awkwardly see if we can make this happen here, and we're going to break the thing here. Like, where's the highlighter? I need a highlighter, and I need to mark on this thing, and we'll bring that's. We need the arrow, and we're going to bring up this thing, and we're going to look at this slide here. Maybe not. Maybe this never works right. Go over there, and we'll bring this down here. No, I don't want that one. I want the next one up. So don't whine. Stop whining. No one likes it when you whine. Okay? So I want this data right here. Okay? So let's break out the highlighter. Here's my highlighter, and it says, okay, we're under the condition of having survived. So what that means is with my highlighter, what I'm going to say is that given that you survived, and I'm looking at just that data right there. So I'm redefining my population of those that survived. And I say, oh, for those that survived, first class would be 203 people, second class would be 118, third class would be 178, crew would be 212. You could give the total, it doesn't really matter. But this is the conditional distribution given that you survived. If I said, oh, what's a conditional distribution given that you were second class for survival? Given that you were second class, my population that I would be talking about would be the second class people. That's all I care about. Given that you were second class. There's my new population. 285 people. Of those 285 people, how did that break down? Well, 118 of them survived, 167 of them died. So that would be that distribution right there. Okay, let's see if this is going to do what I wanted to do here at all. Oh, I could have done it that way. That would have been so much easier. All right, let's take, oh, I need to remember that. Okay. So, let's take a look at, this isn't doing what I wanted to do either. And, oh, all right, so here's a conditional distribution of having perished, and my population is just the dead people. Contradiction there. But yeah, 122 dead, 100 first class, 167 second class that were dead, 528 third class that were dead, 673 crew that were dead. Let's see if this is going to work still. It did. Okay, so now we've got, and let's roll this up. Now we've got conditional distribution, and what I have is I have a comparison here between the alive data and the dead data. And if we can go back up, and it's not going to allow me to do it with the keyboard, which is poopy, all right? If we go back up, what we saw from the conditional distribution with the data is that these are fairly consistent. There's about 25% of the first class passengers were survivors, and I should say 25% of those people that survived were first class. That's about where that is right there. And we see the scale right here. And percentages would be better here. And then here we have the dead grouping right here. So, oh, sorry, first class is green. First class is green, and there's third class right there. So, and here we have the dead people here. And the question is, why are we having those two next to each other? And the answer is, that's very, very helpful, because what we're going to do is we're going to compare them. And we're going to say, okay, I'm going to compare these two variables. My two variables are survival and class. And I'm going to say, okay, does one of these influence the other? And the word we're going to use here is independence. Are these variables independent from each other? And we're going to stop here. I'm going to start the next section in just a second, and we'll use an example to help us do that.